We have a colleague who is helping farmers and ranchers become profitable. Soil biology and soil health is the new buzzword, and I'm sure, Steve, you've seen that throughout your career, how it used to be fringy and now it's more mainstream. It used to be, you had to seek it out, and now it's in most of the trade publications, and that's really neat to see. So one of our friends, Josh Adams, is helping farmers and ranchers implement soil health principles specifically through biology. And he's not a product person. He is a process and principles based person. So if you listen to this today and you're like, how do I actually do this? What do I need to do? How do I have somebody that holds my hands and helps me through this? Josh is your guy. I encourage you to reach out to him. His company is called Living Soil Management, and he's been on our ranch. We bought hay from him. He is a farmer at heart. He is very much profit and margin minded. So he's not going to push products on you that are just going to make him money. They absolutely need to work for you as the producer first and foremost. And so I'll put the link in the show notes, but it's livingsoilmgmt.com. And there's links there to be able to connect with Josh and schedule a consultation with him or one of his coworkers or employees. So Steve, where are you calling in from today?
Lexington, Kentucky.
Well, welcome. We're really grateful to have you here with us. For those that are joining us here live, we will be publishing this on our podcast channel. It is the Profitable Ag Steward. You'll get a text message with a link in the next couple of days with the playlist that this will be plugged into. So you can go back and watch that. If you're listening to the podcast and you want to see Steve's slides, jump over to the YouTube channel and you can watch the presentation there. So Steve, tell us a little bit about your background. Are you originally from Kentucky, or where are you from, and what got you into the soil health realm?
Sure, Jared, and hello everybody. So I'm basically a horticulturist and soils guy. I've been doing this for 40 years from Oklahoma. I spent a lot of time in Missouri, Arkansas, Texas, that whole region. And I've been here at the University of Kentucky. I'm the farm superintendent of the horticulture research farm. And I've been doing this for the last 12 years. So been just like everybody else trying to find out what works, right? Yeah, I'll want to share some of the things I've come across. It's going to be short, but I'm going to just highlight some key points on the talk here tonight. So you want me to go ahead and share and
Yeah, go ahead and pull up your
get
slides
started?
and we'll jump right in, Steve.
We'll get in there. Okay, yeah, I think you got the title slide, everybody.
We do. Yep.
So yeah, what I'm going to talk about is carbon farming and soil biology as the foundation of regenerative agriculture. So that's what I want to talk about. And let's jump in there. And you want to get that to advance? There it is. First, regenerative agriculture is what people refer to today, but really, I think that we need to recognize that it's really a progression of a number of holistic farming systems. And so we have about 50 to really 100 years of experience, starting with biodynamic farming in Europe in the 90s. And biodynamic comes across a little odd to a lot of people, but if you dig into it, it is a real premier humus farming system. Excellent job at making good quality compost and promoting soil biology. Anyway, so in the 1970s, you had Acres USA magazine got started on eco-agriculture in the early 70s. And then you had a whole bunch of organic farming organizations get going in the 70s. So we now have 50 years of experience with a number of these organizations who've all had annual conferences for 50 years. And farmers have led the way on what works, on using cover crops and building organic matter. So 1980, a real landmark report from the USDA, the report on organic farming. And then in the late 80s, the ATRA, Appropriate Technology Transfer for Rural Areas program, got started. I worked there for 18 years, traveled all over the country and around the world, speaking and learning about sustainable agriculture, the USDA SERI program, the Sustainable Ag Research and Education program. And then the people hear about sustainable agriculture, eco-agriculture, nature farming is becoming popular, permaculture. What they all have in common is an emphasis on agroecology, or what I call natural systems agriculture. And they all embrace this concept around soil health. Food is medicine, local food quality, very important, and really reduce the toxic load. In other words, how can you build a resilient agriculture system by adopting biodiversity and all these other practices that reduce the need for pesticides. And after all, we're farm families. So, what we spray influences our own family, our own water quality. I've experienced many farmers who have gone this direction because that's where they were coming from. They didn't want to have the exposure to their family. So we talk about natural systems agriculture. What does the natural ecosystem look like? So the three big ecosystems, forest, prairie, and wetland. And here's some key points there is that they're complex mix of above ground plant species, which host a complex below ground soil food web. So the soil development, soil fertility, plant productivity, they're all driven by these soil biological processes. So if you look at the forest, you see in the prairie, you see the ground's covered with mulch, a lot of different species, a lot of different canopies, a lot of biodiversity happening. The prairies have some of the deepest soils in the whole world, hundreds of different species of plants and legumes and forbs that make up the prairie ecosystem. And they are very well adapted to all kinds of stress, whether it's drought or flood. They have really deep roots, have complex soil biology that drives this process. And nobody's out there fertilizing these ecosystems, and look how productive they are. And then the other thing is the fungal succession that happens in prairies and forests, much greater than you'll see in croplands. So the other thing is this, again, this succession, when you see plant species composition changes over time, and from exposed soils, it goes through a succession over many years, you'll end up with a climax prairie or a climax forest. So it becomes increasingly more perennial. There's little disturbance. There's no tillage out there. You have this deposition of all this woody mulch, you have greater fungal diversity, and you have more mycorrhizae fungi. So there's two platforms that I teach from. The three pillars of ecoagriculture is one of them, and that is the minerals, biology, and energy. That's the three pillars. The integration of those three things make up ecoagriculture. And ecoagriculture is really taking the best of organic and the best of conventional. I consider it very sophisticated. The Acres USA conferences in the magazine is kind of the host for this. But minerals, you got soil testing, you have all these minerals and foliars and fertigation, and you're really aiming for crop vitality and nutrient density and pest resilience. Soil biology, by way of carbon farming, involves everything that you can do to improve and manage the soil humus and soil biology. And then last one is energy or biophysics that gets into biomagnetism and the resonance that really there's two things to that. One is that these energy fields are like the software behind the hardware. In other words, the cells, the way our bodies operate, and the way living systems operate, have information systems through energy that are like the software. And then also some of these resonance fields are very healthy. Structured water is also part of that. The other platform, this is one that I'm really into now, and I think this is the heart of regenerative agriculture is build it and they will come. That's really, I think, what some of the really well-known farmers like Gabe Brown are emphasizing is that by adopting and implementing carbon farming practices, in other words, soil organic matter. And if we just took organic farming and called it soil organic matter farming, it would make better sense to most people. Basically, you're building a habitat for soil biology, and then they can therefore perform their ecosystem services by providing that habitat, but again, with the mulch, the soil cover, the biodiversity, the soil humus, the soil organic matter. What does it take? And if you're a farmer, just hang a sign on the door when you go out to work. What does it take to improve the carbon habitat on my farm? So the second one is brew it and spread it. And this is where the modern day compost extracts and microbial inoculants and biofertilizers come into the picture. The toolbox on this is expanded tremendously. And this is where you can get into seed treatments, root zone injections, and soil and foliar biosprays. So this one is from the soil health education from NRCS. This is some of Ray Archuleta's work. This is some soil blocks from nearby sites in southeastern US. And I like showing this because this is really just a quick synopsis of why more and more farmers have really seen the light around soil health and adopted regenerative agriculture because you see these two soil blocks, they're from the same area. And what's going on here? What has happened? Which one has better infiltration? Which has better fertility and function? And every time I show that, all the farmers point to the one on the left. And so what is going on there? And so what you see there is the fact that the one on the left is from a forest site, has a really good level of soil organic matter. as water stable aggregates. And the one on the right was a similar type of soil to start with that's been cleared and put into soybean monoculture, basically industrial agriculture, PK, fertilizers, herbicides, the whole industrial ag model. And you've lost the soil organic matter. It's dipped down quite a bit. The other thing is that you see that you're getting a lot less infiltration, a lot less biology, a lot less porosity, just functionality. So when you do a dispersion test, that will puddle. And when you see this puddling, that's a big deal. That is the basis of soil health and soil structure. It's driven by the biotic glues that come from soil biology, holding that all together. And so I love this illustration. This is from a USDA leaflet in 1952. Back then, it's old soil conservation service. They understood all this. Is your soil crumbly or is it cloddy? And so there in the top right, this is water stable aggregates. They actually went to a cornfield, and on the edge of the cornfield was the fence where a virgin prairie was. They took some of that soil, they shook it up in a jar, spread it out on the table, and those aggregates were still intact. Then out in the cornfield where they do a lot of cultivation, this is before people had adopted a lot of cover crops. They're just cultivating it like crazy. They lost these aggregates, and that soil would disperse or it'll puddle. That's a huge difference between those two soils in their functionality. And so a modern look at soil health, this is what it looks like. Black cottage cheese. That's a really good image of that aggregation that you're after. And again, all that aggregation is from the soil biotic glues that you're promoting through habitat management and carbon farming. And so this is the result is, do you have good infiltration or do you have puddling on the soils? And this is where a lot of farmers have seen this. They've got a lot of good things going on. They see a lot of infiltration on their farms, and they look over at their neighbors and they see all this water standing on the soil. And if you have a little bit of slope, you'll see some erosion. This one's, you don't want to see that on the bottom. Even a little bit of sheet erosion will add up over time. So that's really important to understand these basic concepts of what soil structure is, aggregation, and the reason that you get that soil structure and aggregation is through carbon farming, paying attention to soil organic matter habitat, and promoting soil biology to get those biotic glues. And then this is another example. Here's a row crop operation in Pennsylvania at Rodale. And over time, just the way you manage the soil makes a difference. And that's really ultimately what sustainable agriculture and regenerative agriculture is. It's just the way you manage the soil. It's the same soil, it's the same crop, the same climate, but the way you manage it, because you understand these principles and you can implement them, you can make a big difference. And so the difference between 2% organic matter and 4% organic matter in your soil is huge. And when you achieve that, you have more functionality, you have better resiliency, you have better natural fertility, you're aiming for better pest control. And it's all around functionality. This one, I like this one. I actually got permission to use this slide. This is in the South Africa. A lot of people go to garden centers, they see succulents, these weird cactus looking like plants. This is where succulents grow, is in these desert regions of South Africa. And so you see this fence line, you see a pretty good sized difference between barren soils on the right. You have a lot of vegetative cover on the left. And so that's what is known as the paradigm fence, because, what's going on here? And, this is popular even in the Western United States. A lot of environmental do-gooders have this idea that grazing is bad. You need to remove the cattle, prevent this overgrazing. But in actual fact, this is what's going on. The farmer on the left was influenced by Alan Savory. He adopted holistic grazing. He's doing more of a mob grazing, moving them through there, letting high impact, a lot of manure deposition, then a rest period, and then return. Just same way that bison would graze on the Great Plains. And on the right, they've done more or less conventional grazing, extensive grazing, let the cattle run around, eat the grass down. So you have this loss of vegetative cover, loss of or soil organic matter, or carbon, loss of soil moisture, huge difference. And when you add all this up at the watershed level, you can really make some big changes. And so, yeah, that's a really good illustration. That concept is a real, it's really helped people understand that, is that the way that you manage the land can make a big difference. And so just an example, bison, we had millions of them in the 1800s. We don't even have that many cows in the United States today. But again, it's this animal impact. That's where, grazing is actually a tool for carbon farming. And so, anyways, this goes on. One of the epic discoveries in soil science took place in the 1890s, 1880s, and that was discovery of mycorrhizae, or the fact that fungi will inhabit plant roots and create a symbiotic relationship. And so in reality, that was discovered in the 1890s. And then in these, we discovered that the mycorrhizae produce glomalin, which is a soil glue. It goes in the soil. It increases soil carbon. It helps these really flimsy fungal mycelium to remain intact so they can act as tubes to channel nutrients to the plant. The plant does photosynthesis. It provides carbon to the fungi. It's a symbiotic relationship. But we're discovering all this now with our modern science and tools, and yet in reality, this is how nature works, and this has been going on since land plants got started 450 million years ago. So they've had a long time to figure out this association. And so this is one of the really awesome things about soil biology is mycorrhizae and the importance of fungi and all these different relationships. So then things have evolved rapidly, and nowadays pretty much everybody is on board and understands that there's a microbiome. Every single living organism on the planet, every plant, every animal, every human has its own microbiome. And so we talk about the plant microbiome, the rhizosphere, the three-dimensional zone around the roots where plants live and where microbes live and inhabit and interact with the plant roots. We've got the phytosphere, the same things happening on the leaf surfaces, three-dimensional zone around the leaf surfaces with microbes. And then actually plants are living inside the plant. And then on top of that, we have a huge, vast soil microbiome. So all this is the eating up modern science. We're discovering more and more about this all the time. But this is essentially the backbone of the understanding that all life on the planet has an underlying hidden sphere of microbial activity. And so when we talk about, said that we promote carbon farming to provide a habitat for the soil food web or for the soil microbiome so they have a place to live and perform their ecosystem services. And this is what I'm talking about. So again, we've got these two action zones. These are the two areas that actually farmers have the ability to modify and manipulate is the rhizosphere and the phytosphere with the practices that you do when you're doing foliars or you're doing root injections and fertigation. And then what all these different things they do just goes on and on. They do nitrogen fixation, carbon fixation. They're involved in transformation and availability of nitrogen, phosphorus, and sulfur. A lot of people have heard about phosphorus solubilizing bacteria, but there's also potassium, manganese, and zinc solubilizing bacteria. Pretty much every mineral. And then they're involved in biological control. They produce phytohormones, and they produce the two workhorses, which are organic acids and soil enzymes, and then these biotic glues, these slimes and glues that are very important in soil structure. So that's really helpful to grasp that and understand that. And so this is where I want to share an example. So let's just take one single microbe. And that is algae. This one is all the different metabolites that can be produced by algae. And so you have these different classes like phytohormones. And then underneath that is a whole list of phytohormones, signaling molecules, antioxidants and micronutrients, polyphenols, polysaccharides or these glues, et cetera. This is all the kinds of things that the algae can produce. So they're involved in growth enhancement, in other words, these metabolites that are produced by the microbes influence plants, and they talk to plants, they communicate with plants, and they influence the plants through growth enhancement. They help them with tolerance to stress. They help them with induced disease resistance and nutrient mobilization, antioxidants, and other metabolites. So having said all that, I love that example. And the same thing is with yeast, a very simple microbial cell does the same thing, very powerful. And so we have actually done a little research on this at our greenhouse. This is an example. So on the left, the bottle there is in-soil algae. This is one that's really popular now. It's Chlorella vulgara. These are live algal cells that the company sells to the farmer, and you use them in your production system. The one on the right is actually an extract of live algal cells. So it's pulling the metabolites out into the solution. It doesn't really focus on the living cells. But these are a very simple demonstration. This is coleus. It's an ornamental plant. I work in horticulture. We do fruits and vegetables in greenhouses. So we did this little trial. We put coleus in plain water on the left, and after it takes about somewhere between 17, 19 days, they'll start forming these little roots, and it'll root out, and you can propagate plants that way. So we did the same thing. We put the algal biostimulants in the water, and look at the difference in the rooting. And that incredible extra massive rooting that you see on the right is from this stimulation of the microbial metabolites, either from the living cells or from the metabolites that have been extracted from living cells. They both do the same thing. So you get overall early rooting and overall massive rooting. This is just a really great visual demonstration of the power of these microbes and what we're talking about. And so this is a crop input. You can purchase these products, you can grow your own microbes, and you can also manage the habitat. Because believe me, in the soil, when you're managing the soil habitat through carbon farming, you have gazillions of these working for you. You don't have to purchase these. These are just an option to put into your cropping system. So if you're doing row cropping and you had this and you were able to do root zone injection at the time of seeding, you would have a seed treatment and you'd have the ability to stimulate the roots. And as the plant grows and the roots expand, they're carrying these microbes, these microbial associations with them in the rhizosphere. So that's a really good demonstration. And then, so just based on my conversation with Jared, here's a few key points I wanted to share on grazing. I've worked in grazing. I'm a horticulturist, but actually, I'll tell you a story here in a second. I've worked in grazing in Texas, and we kind of went from rotational grazing to basically mob grazing. And so we were really convinced. Oh, you got to have fencing, you got to have water. And what's kind of cool nowadays are these virtual fencing collars, because there's a lot of labor in moving these fences around. So mineral blocks, free choice minerals. Ian Mitchell Innes visited our ranch, our farm. He worked with Alan Savory in South Africa. He's really big on free choice minerals. Some great stories about animal intelligence, how they know which minerals they need at what time. And in our situation, we developed a lot of technology around liquid biological amendments. So I'm going to share that here in just a second. And then on row cropping, no-till's big. No-till's not the only way. So you got no-till, which is K-N-O-W. So you just need to know how to do the right tillage for your farm. Where you live makes a difference. We're in a more humid climate, a lot more rainfall here in Kentucky with 44, 46 inches of rain a year than in Nevada or in Texas. So this depends. Multi-species cover crops, huge droves with intercropping, huge roller crimpers, integrating livestock grazing with row crops because you've got all these cover crops working for you. And then this is where you get into sophisticated soil and sap analysis testing that can lead to targeted minerals and trace elements. And then your seed treatments and root zone placement of your biofertilizers and other things you can do on the farm, like vermicompost and Johnson Sioux compost. I think these are the key points that we could go into, have conversations about. Let me just give you some other examples. So this one is on multi-species cover crops. And so basically the biocomplexity that you can manage for above ground. In other words, by increasing the diversity of your cover crop above ground, you are going to influence the below ground soil food web. And so when you do this, there's what I call a tipping point for biodiversity synergy. In other words, David C. Johnson, his work with the biological farming method with the compost extracts and cover crops in New Mexico said you need at least a 6-way cover crop. Christine Jones in Australia talked about a 12-way cover crop. Then the Jenna Farm Field Trials in Germany talked about 8-way to 16-way. In other words, when I say that's 16 different species or 12 different species. So, and what's important is getting 4 or 5 plant families in this mix. So the point there is that when you aim for this greater complexity of biodiversity, there's a tipping point where things start clicking. The soil health starts clicking, the natural fertility and pest control all start clicking. So that's a really important one. Now, this is some of my work in Texas. This is Betsy Ross and J.R. Bilter, her son. This is a ranch northwest of Austin, about 560 acres. They did grass-fed finished beef. And what happened is Betsy had another career. She grew up on a ranch family in West Texas. They had this other farm over there in, Central Texas. And she went to manage the farm, learned about the soil food web, studied with Elaine Ingham, started doing compost teas, and started getting so many good results that she developed a whole company around that. And that's why I went down and worked with them. And so, like I said, started off with rotational grazing, moved into mob grazing. You can see the forage base there is really nice. That was a good year. I was also there in some really incredible drought years. The driest year in history of Texas was like 2011, incredibly dry. Oh yeah, did used to do cow calf operation. And they went away from that, did all steers. So they would have 250 herd, 225 herd, and they would just mob graze them and strip graze them. And learned to work with cattle, learned to move them. It was very interesting. You really learn a lot more about herd behavior with cattle. They really like to live in a herd. There's something about that. They like living close to each other and moving. But yeah, that was all trample grazing or mob grazing. But the other thing we did was these, what we call liquid biological amendments. And so there was a guy named Dennis Fronick. He was also a student of Elaine. He developed this compost extractor. He's got a patent on it. You can actually read the patent. You can build one yourself. But commercially selling them was tied up in the patent, stuff like that. So this was a compost extractor. It's got a conveyor. It's got washing units, and we would load that up. The manufacturer specs were 2,000 gallons an hour. We made some modifications. We were able to make 3,000 gallons an hour. We have 2-inch hoses, banjo clips. You see, it's pretty practical farm technology. And one of the key things is that a lot of modern day people talk about compost. One of the key things I want to point out is that we never really just relied on one single compost. We would always have like 3 or 4 different kinds of compost that we would feed through there. A lot of this gets into custom blending. Depends on what kind of a cropping system. Is it a prairie? Is it a turf grass? Is it a pecan orchard or vineyard? And based on that, you would custom blend for like more fungal, etc. You're really after the diversity. That's why you have several different kinds of compost. This is another example. This is a unit called the GOT. The GOT, why I'm pointing that out is that these are available to farmers.
I think we just lost your audio, Steve.
Can you hear me now?
Yep.
I'm sorry about
Just
that.
where you.
I lost my mic turned off. Maybe it's run out of juice or something like that. So
Okay.
the thing about this one, you can make a tea out of this, or you can make an extract. So it's versatile. This is one of the commercial units that you can get. And basically, you're agitating, you're extracting the biology. This is what you're talking about. You're talking about pulling out the microflora, the bacteria, fungi, and then also your protozoas and nematodes, which are grazers. And so that's what's going into solution. That's what you're spraying out onto pastures or row crops, or you either spraying it out or put it in a root zone placement. And then what I call biosprayer technology. So this is interesting because this technology is sold for pesticides. What we're doing in regenerative ag and organic is we're taking the same technology and we're dedicating it for our biological amendments. And so this is going to be a tank blend. We're going to have the compost extract in there. We would also brew our own microbes that go in there. We'd have some humic acid, some seaweed, some molasses. We could put some trace elements like rock minerals in there. And that would be a custom blend that would go out onto the land depending on what crop you're after and what time of the year you're after. And so that's we would typically do 20 gallons per acre. So that's a 500 gallon tank on a 1-ton truck. So that's 25 acres. You got a 1,000-gallon nurse tank, so you can pull that combination out. You can go to the field and you can apply a lot more acres that way. You can just fill back up. And then we did some really interesting work there. Like I said, on some good sized ranches and prairies and pecan, a lot of work in pecan orchards. And then here's the other thing that was go behind this. There's a guy named Carl Oppenheimer. There's a movie that came out a few years ago about the Carl Oppenheimer, the nuclear physicist who built the atomic bomb. But that's not who I'm talking about. This is a microbial biologist at University of Texas named Carl Oppenheimer. He worked in the oil field bioremediation on oil spills. And so the terminology that they use in that that field is bioaugmentation and biostimulation. So I basically adopted this for agriculture. The concept is the same. Bioaugmentation means you're adding microbes. For example, your liquid compost extract, anything that you're brewing, microbials, mycorrhizae. We went through trailer loads of mycorrhizae inoculum, and then you're adding the microbes, and then you're feeding and stimulating the microbes, both the indigenous microbes and the ones that you're applying with foods, microbial food sources. So like molasses and fulvic acid, helping humic acid, and so forth. So this is behind the concept behind liquid biological amendments. And all these people in regenerative ag are doing grazing and row crops. You can adopt this. And then one of the other projects we did was the G.W. Bush Presidential Library in Dallas. We were the soil biology experts that were hired by the landscape firm to do this. And I actually wrote the soil specifications for that. And what we did was we actually used fungal-based biology. There was a concept going around for years that all grasslands are bacterial, and based on the soil food web testing that we did in Texas on tall grass prairies, we found that these actually have a really higher level of fungal. And so that's the kind of compost and the kind of extracts and things that we would blend. And so that's what we did. Really successful project. And there's just a few more things you can do on the farm. You can have your own worm composters going. Worm compost is super rich with biology and humic acids and fulvic acids, all these synergistic blends. So that's something you can do on the farm. This one is also very popular nowadays, is Johnson Su bioreactor. And you look at the fungal to bacterial ratio. So that's what they're aiming for. You're basically aiming for a microbial inoculum with this kind of compost, and you get a higher level of bacteria. People are running these samples through like a microbiome lab. They're getting one of the guys I work with, we sent it to the lab, and he got like 1,000 different fungal and bacterial species on his lab report. And so this is large scale. This is at Living Sky Grains up in Montana, and he's got dozens of these reactors going, and he's really into it. And he's putting it out with his grains. He's getting his rhizose sheaths up there on the right. And so this is being adopted on a large scale as well. And so just a couple other few things you can do. This one is now also popular, is more effective microorganisms. And the reason I mention that is for row croppers. The Terra Organics, the one on the left there, has a nitro protocol. So they have a way of brewing urea with the microbial inoculant, and they're talking about cutting back on nitrogen inputs by 50% doing this. And so the one on the right is in Kansas City, SCD probiotics. So there's a way to brew this on the farm. It's very multi-purpose microbial inoculant. And then here's another one. This is a whole bunch of these different biofertilizers. This one is labs or lactobacillus. And so there's a way to do this on the farm. This one is also really powerful, really good disease suppressant, also good on foliars. And then, this is where it all comes together. This is what farmers get excited about. When they see this in the field, they see the rhizose sheaths forming, what people call dreadlock roots. And this is from the plant exudates and the mucilage and the microbial slimes in the rhizosphere. And it's where the soil clings to the rhizosphere. When you pull it out of the ground, even if you shake it, it holds on there. And so this is a really good sign, a really good indicator of soil health. And again, farmers getting excited about this. They're trying all these things out. It's definitely a journey. Soil health is a journey. It doesn't happen overnight, but that's fine. That's the way the world is. That's how farming is. It's a 40-year learning curve. That's what I've been doing all these years, and I'm still learning. So we got a lot going on here, but this is a little small horticulture farm. We do a lot of cover crops and living mulches. I do some trials on biofertilizers and brew things. But anyways, that's a really quick overview of soil biology and carbon farming. I hope it makes an impact on people's minds. We know the science is solid, and we know, because a lot of farmers are doing this, how to do it. It's just a matter of taking steps and trying things out. And it takes a while to implement this stuff and move down the journey. But we know that a lot of these things work really well, and we have a really good toolkit nowadays to help farmers out.
Wonderful. Yeah, that is an amazing overview. We appreciate that, Steve. For those that are here live, if you have questions, you can put them in the chat, or you can raise your virtual hand. And if you have a good internet connection, we can ask you to unmute and ask your question here of Steve. So Steve, backing up to succession and the question that I had about climax species in the tall grass prairies. Is grass the climax species? Did it ever progress beyond that to more of a woody species, more fungal dominant?
Yeah, it's well, the prairie also was managed with fire, and even the indigenous peoples, did that.
Mm,
And even today, if you're managing for a prairie, you still use fire as a tool because you will get encroachment of woody plants and stuff like that. So that's kind of a management thing. But the prairie is a climax vegetative ecosystem by itself. But I have another set of slides I use. This is very interesting. Is that people have heard about allelopathy, and there was a professor of botany in University of Oklahoma, Roy Rice, who did a lot of work on that, and he studied abandoned farms and the succession that happens on abandoned farms, and how over a 50, 60-year time frame you went through the succession and you ended back to a prairie. And so one of the things that this is very interesting is that he found that there's a tie-in to soil biology, because early in the succession, the certain kinds of microbes would prevent the prey from succeeding, and over time that would change. And so there's an underlying soil biology behind this succession. And
hmm
so yeah,
Yeah, interesting.
and
Right.
it would shift over to promote the better quality species and so forth.
So would you say that the succession is happening just as much below ground as above ground?
That is that's the tie together. It's like a mirror image. And here's the thing that we did with, again, going back to the liquid biological amendments, and we did work with prairie restoration. I did some work with very degraded lands. And so in reverse, if you understand that the to promote a vegetative shift, that's where you can come in with these biosprays. If you understand you're trying to shift the forage base or the land to become higher quality succession, better quality forages, this is where your custom biosprays come into the picture, because the way you can blend that with the fungal foods and the fungal based compost extracts is you're promoting that succession. Now, plants are definitely the driver of soil biology. That is for sure. Plants are the reason that soil biology develops in the soil. They're the interaction there. But what I'm saying is that these biosprays can help push that succession faster.
Yeah. Um, yeah, that's great. With people learning about regenerative agriculture and the importance of soil health, sometimes I know from personal experience it can be overwhelming. Like, where do you actually start? Do I start with cover crops? Do I start with biologicals? We're in a grazing context, and so I think I default to doing it with livestock. But what would you say for, let's just say, the average, we'll pick rancher, grazes, puts up hay to be able to feed the herd of livestock? Where would you recommend that they start to make a shift towards a regenerative model?
One of the things I didn't make a point about, but I do believe that the management is at least 60 or 70% of what you're aiming for, and these various inputs make up the other part. I don't think you can turn it. I don't think you can flip that around.
Yeah,
And
you can't
so
overcome bad management through
yeah,
anything, right?
right. So
We've tried it. We've
on
tried it
grazing,
for
I'm
decades.
really big. I'm really big on strip grazing and mob grazing. I think you'll see the benefits there. I think these virtual collars and fences are going to help farmers do that, because there is a lot of labor to do the management on moving cattle. And the other thing is bale grazing in strips. And even one farmer that I knew did New Zealand bale racks, and what they would do is they would roll out some hay on the ground in front of the bale racks. They put the hay bales in there, and the cows are feeding in the winter. They're pooping on the hay and stomping it on the ground, and they would just move that through the field. And you can spread some rock dust on there. You can spread some rock phosphate on there. They can trample that all down together. And so that's a really another great way to use your cattle to help your soil.
Yeah. Yeah. I'm a big fan of that. Integrating livestock, letting them do the work for you. That's one of the quickest ways to be able to regenerate degraded soils.
Some of the farmers are doing multi-species grazing. Some of the really big regenerative farmers who are well known, Will Winter and Gabe Brown, they're all doing multi-species grazing, because Joel Salatin. So you've got
Hmm.
cattle out there and you have some chickens out there, whatever. So they're poking through that. It's biodiversity with animals.
Yeah. Yeah. Makes sense. What's your opinion of the Maha Make America Healthy Again movement, and specifically the dollars that are earmarked towards regeneration?
I don't follow it closely. I know a lot of people in my network are big on Maha. Obviously, that's a great thing to be more healthy. And again, I think let me just say that the paradigm fence is a good example. Is the paradigm fence on the right? You've got this barren land, and so the sort of environmental thinking, or maybe the urban environmental thinking, is grazing and animals are bad. Take them off the land, and that's really not true. And it's counterintuitive. And actually, in land management, we know that increased grazing that's done well with a holistic grazing plan can improve those soils. So again, it's the way that you manage things. I think Maha is the same way. I don't think we should put everything in the same basket. We should be open to things that are healthier for us, and sometimes it goes against the grain. I don't know about the money that's going in. I know they took some money out; they're putting some money back in. I'm not
Yeah.
following what's going on, but if I know some of the money that was taken away has come back to some of the organizations I'm working with who are working with farmers, and they are putting money into conservation practices,
Mm.
which is great. Farmers can get $15,000 to implement some kind of practice to try out, and then people learn from that, and the next farmer learns, and after a few more years, we know more than we did before, right?
Yeah. Yep. Florencia asked the question, what are the ways to introduce and promote these ideas to old school traditional producers, specifically those that are leaning towards synthetic systems, highly synthetic chemical fertilizers, herbicides, pesticides?
The incentives work. People make changes based on different reasons. One of the reasons that farmers will change is there's an incentive. So the money that we were just talking about that are available for implementing conservation practices, that's a good way. If they're opening to joining that program, getting some funds, trying out some conservation practices, whether it's some kind of cover crop or doing something around whatever, they can learn from that, they'll be more inclined to adopt that. I will say that one thing is that farming as a profession is very conservative because farmers are risk averse. They have a lot tied up in their operation. They know what works based on the way that they've done it, the way that their dad did it, and they don't want to change because they don't want to have a hiccup with their economic model and everything's tight. The returns, especially in the row crops now in the Delta, in the Midwest, are very things are very tight on
Yeah.
economic return. So
Yeah.
so yeah, that's it. I've been around, like I said, for a long time. I was involved in holistic grazing in the 90s, and there's parts of Oklahoma and Texas that I worked in that has not changed very much. So, yeah, that's the way it is.
Yeah. Yeah. Good answer. Florencia, that's one of the things that we teach at Ag Steward is lead the way. Profitability speaks to farmers and ranchers. Everybody wants to be more profitable. And if you can show that through your practices, you're able to reduce inputs without sacrificing yield, that speaks to people. I think that's one of the biggest fears that they have, right, Steve? Is that if I switch to this, we've all heard the horror stories of yields just falling through the floor because we were missing some of the key pieces of how to be able to make that transition from the chemical dependent model to the biological model. So yields drop, the farmer gets stressed, the banker's breathing down his throat, profitability suffers, and that's not a good place to be. How have you seen that transition happen with those that are successful without going through that yield dip?
Yeah, that's a good question. But let me just say in general that so my comment about regenerative agriculture is that it's really about build it and they will come. It's really this kind of adoption of carbon farming and soil biology as the foundation. And one of the other things about the things that I think has been really great about regenerative agriculture is again, it's a progression of what people were doing in organic, and organic people learned, and sustainable agriculture came around. It kind of expanded. Organic is kind of a subset, and it appeals to certain people. Some people have the right kind of market to go organic. It's just not for everybody. What happened when farmers like Joe Salatin and Will Winter and Gabe Brown and Rick Clark and these people are demonstrating it, and Jared's out there in Nevada They're demonstrating how this works, and they're broad scale farmers,
Mm.
and other broad scale farmers see that, and that's a great living example. That is where
Yeah.
that's really where the emphasis and the progress has really catapulted, I believe, regenerative agriculture.
Yeah, I would agree. I would agree. There are those that are doing it at scale, that are doing it successfully, that have models that can be duplicated. Not exactly, because your context is going to be different, but certainly if you look at the underlying principles, what Gabe Brown is doing, those principles work here in Nevada in a very different environment. Less rainfall, less heat units in the summer, less.
Let me give you one more example. So in Kentucky, we have one of the things that we're popular for in Kentucky is bourbon, actually. And so Maker's
Mhm.
Mark is a famous distillery. It's beautiful, historic, national historic distillery. And the bourbon industry, what they do is they use corn, wheat, and barley. And so they contract with growers in a 60-mile radius around the Loretto, Kentucky. And so I actually was involved in helping Maker's Mark go more regenerative, and provided the I think I helped provide the um, the know-how and the confidence that they could do this.
Mhm.
They hired understanding that they've gone with the Regenified program, and so basically here's a marketing angle that has made a big difference. So if you're a farmer contracting with Maker's Mark and you're raising corn, wheat, and barley, you're required to get in the Regenified program.
Yep.
So that's that. All of a sudden, there's 60,000 acres in Kentucky that have gone Regenified because the market has asking those farmers to do that. And so that has been a huge impact on soil health practices in Kentucky. And I've been in workshops with these farmers, and they're all down for it. They totally get it.
Yeah.
Yeah. But
I
they had a market incentive to do that. And so that's another good example is the market incentive, plus a
yeah.
government payout incentive and a market incentive.
Perfect. Yeah. I think that's the right approach. Incentivize it through a market, value added. And if that label means that you can sell your crop for more, then it's absolutely worth jumping through those hoops. And at the same time, you're going to be doing better by the land, because you will be not just getting a label that says you're regenerative, but there's a lot of credibility in the Regenified. We use land to market, or the Savory Institute model, ecological outcome verification model for our ranch, because it's more based on grazing. But you've got to meet the criteria, otherwise you don't get the label.
Right.
You don't get to stay in the program. And so I'm all about that. Good, good
Just
answer.
as another example, the Betsy Ross grass-fed beef in Texas was part of a coalition of grass-fed beef producers who produce for Whole Foods. And all of the Whole Foods in Texas, Oklahoma, Louisiana were all supplied from these grass-fed beef operations in Texas. Another market incentive.
Yep, absolutely. Well, this has been great. We thank those who've listened to us live. We especially thank you, Steve, for being here on with us today. If you're okay to stick around for a few more minutes, we'll do an informal Q&A. We'll keep it really short. I'd also like to incentivize a winner for somebody who stays on. We'll want to give out a prize for those who are here live. So thank you, everybody, for listening. Steve, final thoughts for our audience today.
Well, everything's gotten better over the last, so many years. Our technological know-how is better. Our equipment, our products are all better. So it's a really great time for farmers to have the ability to get into regenerative agriculture. And, it's kind of exciting. It's, making things better and, keeping profitable, raising quality crops and livestock. So yeah, all good, and appreciate the time to share with y'all.
Well, thank you. Yep, we really appreciate you being on here. Thanks for those that have been live. For those that are listening to the recording, continue to check out what we do on the Profitable Steward Podcast and Profitable Ag Steward on the YouTube side. Look for upcoming events that we have. We have a 3-day challenge the middle of March. If you're on our email list, you'll get access to that. You can look for us also on Facebook and find a link to be able to register for that here soon. Be blessed, everyone, and have a great day.